So we're about to increase our functionality dramatically in chemistry by introducing the term or concept of the mole. So what is a mole? A mole is 6.022 times 10 to the 23rd things or objects, right? The mole itself is just the number, but anytime we're talking about a mole, we're always talking about a mole of things. A mole of particles, a mole of atoms, a mole of ions, a mole of something. For example, what if I said, what is a dozen? Well, the question itself doesn't make much sense. I guess the best answer to that would be 12. Can you see there's the number for a mole, here's the number for 12, here's the number for a dozen. But if I said, I have a dozen in the car, you might say, a dozen what? That would be the most natural thing. A dozen cookies? A dozen eggs, right? The term itself doesn't mean anything until I put something with it. I mean, it's a number, and that's all a mole is. Okay, so the reason we use a mole is because it's not convenient for us to talk about how many atoms we have. Because usually when we're dealing with things in a macro scale, it's a really big number. We're dealing with billions of billions of billions of atoms. For example, how many atoms are in a penny? Well, that doesn't make, it's difficult. It's a very big number, right? Something times 10 to the 20, 21, or 22, or 23. Probably 22. Something times 10 to the 22. But if we say moles, now we could say, aha, okay, well, 1 mole of pennies, or rather, I should say 1 mole of copper atoms, now that's something that you can hold in your hand. Okay, so about 22 copper pennies contain 1 mole of copper atoms. So can you see how if we use a big number like a mole, we can start talking about the number of atoms in a reasonable number. Like that's a number that you can put in your hand. Okay? So and the mole is like the conduit for that. Well, what is 1 mole of water molecules? It's about 1 tablespoon. So again, can you see how we could say 1 tablespoon of water, and if we take that in terms of moles, that becomes a very manageable number for us. And this is about where we live, right? We live in a tablespoon or a gallon or half a gallon or 20 gallons, but that's sort of where we are. We don't say 5 billion gallons. I mean, 5 billion gallons might be the number of gallons in the ocean or something like that, but that's not where you and I are doing our work in the chemistry laboratory or in the field. It's typically in terms of tablespoons, milliliters, liters, gallons, and such. And so mole becomes a very convenient number for us to work with. Now what we're going to do then is we're going to think about, we're going to measure atoms and molecules in terms of their mass. That's convenient for us because we can just use a balance. And we're going to relate the mass to the moles by using a concept of the molar mass, which will make more sense as we do some problems here. Okay, so we're going to count atoms by weighing them with molar mass, and then we're going to do a lot of conversions. And there'll be a lot of times when we're going to be saying, well, let's convert the number of moles to the number of atoms, or let's convert the number of atoms to the number of moles, or let's convert the mass to the number of atoms or moles, which is super common in chemistry and physics and gives us great power. So let's go to our first example, converting between number of moles and number of atoms. Calculate the number of copper atoms in 2.45 moles of copper. All right, so first thing we do is we write down what we know. We were given how do you spell 2? Like that. 2.45 moles of copper, okay? And so we write down what we know, first of all. Then we ask, what are we being asked here? We're looking for atoms. Okay. So we know that 1 mole is equal to 6.022 times 10 to the 23rd atoms, right? So we're trying to calculate atoms, and we're given moles, We got to find a conversion, and here's our conversion right here. It's the only conversion we have. So that's our conversion. Got to cross off moles and introduce atoms. That's what we got here. Okay. Okay, let's go here. I'm trying to change the color here. Not getting anything. Okay. So let's just put our numbers here. It would be nice to have a different color, but I'll figure out how to do that later. For now, it's 2.45 moles, right? Use that number. And then we've got to put these numbers in here. There's 6.022 times 10 to the 23rd atoms for every 1 mole. Agreed? So we multiply those two numbers together. Pull out my calculator here. Just a moment. 2.45 times 6.022 times 10 to the 23rd. Yeah, and that's going to give us 1.4753 times 10 to the 24. Okay, now we got to go back. Last thing we do is we say how many sig figs. This one's got 3 sig figs. This has 4 sig figs. And so this is going to have 3 sig figs. So this is going to be reported as 1.48 times 10 to the 24. Atoms. Handwriting's getting worse. Atoms, there's 1.48 times 10 to the 24 atoms in 2.45 moles of copper. Okay, so let's do another example. Let's calculate the amount of carbon in moles contained in this many grams of pencil lead. Okay? Well, now we're going from, we need molar mass. So let's first of all write down what we know. We're looking for a mass, or whether we're given mass of carbon, right? And it's 0.0265 grams, all right? And we look up the formula weight of carbon. This is in your periodic table. And it's 12.011 grams per mole. Okay. Calculate the amount of carbon in moles. Okay. And so we're gonna, if we need moles, and we're given grams, and so we got to think of some conversion between there, and we have it right here. There's our conversion. All right, grams. It's got to go on bottom so it crosses off. Agreed? Look at that. Boom. So the number of grams is 0.0265, and it's 12.011 grams per 1 mole. So let's calculate that. 0.0265 times 12.0, or rather I should say divided by 12.011 gives 0.00220631, right? Now we have to say how many sig figs are here. There are 3 sig figs in this number, 5 sig figs in this number. So this gives us, we have to say it in 3 sig figs, 2 to 1 moles of carbon. Okay, so there's our answer for that one. Let's do one more. The mole concept, converting between mass and number of atoms. Okay, so how many copper atoms in a copper penny with a mass? Getting a little overwhelmed here, so I'm just going to start writing what I read, okay? Mass is equal to 3.10 grams. Assume that the penny is composed of pure copper. Okay, so what we need is we need atoms, and we're given grams. right? So we've got to set up a conversion. The problem is we don't have any conversion between grams and atoms, but we do have grams to moles, right? And so we have to look up the formula weight of carbon, or rather of copper. Man, I think I'm going to look that up real quickly. It's 63.546. 63.546 grams per mole. I've got that. Okay, and then finally I can get rid of moles and introduce atoms, and this is Avogadro's number, right? Because 1 mole is equal to 6.022 times 10 to the 23rd atoms. Okay, and the final thing I got to do is put my numbers in here, and then multiply or divide. So what number goes with grams from up here? 3.10. Now grams per mole, where's that? It's right here. So it's 63.546 grams per mole. And how many? And where do atoms and what numbers go with atoms and moles? Looks like 1 mole gives 6.022 times 10 to the 23rd atoms. Okay, so let's say 3.10 times 6.022 times 10 to the 23rd divided by 63.546. Is it 546 or is it 456? Yep, it's 546. And so the answer is 2.9377. 2.9377 times 10 to the 22. Okay, so how many sig figs are in this? There are 3 here. There are 5 here. There are 4 here. So how many sig figs do I need in my answer? That's right. I'm going to have to report this with 3. So this is going to be 2.94 times 10 to the 22. Well, I got to do something with my handwriting. Atoms. Okay. All right. So welcome to the mole concept, and my hope is that you will find it very useful and very powerful for you in your work in the remainder of the semester.